Hello and welcome to Math with Siddig. Today I'm going to talk about trigonometric ratios. If you are in my current geometry class, then this is what we did today while testing was happening. So I'm going to upload this today so that if you didn't get it in class today, you have it now. If you are not in my class, this is still information about trigonometric ratios, and hopefully it will help you. Okay, trigonometric ratios are ratios you use to solve for angles or sides in a right triangle. All right, so the idea here is you have three trigonometric ratios and they're set in stone. But what changes is the side measures, and what changes is the angle that you use. So there are three trigonometric ratios. The first one is called sine. All right, when we write it, it looks like sin is short, but we still say sine. Okay, theta just means angle measure. We have cosine, which we write as cos. And then we have tangent, which we write as tan. Okay, this is just the angle that you're referring to, and you'll see what I mean in just a minute. Okay, there is a shorthand to remind yourself of the trig ratios. All right. I did not create this. I did not invent it. I learned it from another teacher, and I like it because it is memorable. And when I was in school, they just had you memorize this, and it was not that helpful. So the phrase to help you remember is some old hippie caught another hippie tripping on acid. Okay, and what that stands for is it stands for the parts that make up sine, cosine, and tangent. That was a terrible little wiggly thing. I don't know why I dotted that. It's been a long day. All right, so the idea here is some old hippie just helps you remember the order, the S and the O and the H. Okay, O always stands for opposite, and H always stands for hypotenuse. So sine is the opposite over the hypotenuse. Okay, cosine, the caught another hippie, reminds you of the CAH, and that's cosine is adjacent over hypotenuse. So notice, every time that H shows up for hippie, it stands for the hypotenuse of the triangle. All right, then the last one, the tripping on acid, stands for tangent, and the O and the A, once again, stand for words and letters we've already seen, which is opposite and adjacent. So tangent is opposite over adjacent. Now, the way that you figure out how to set up the ratio is based upon the idea of which angle you're looking at, because there are two unknown angles or two non-90 degree angles in this picture. I have one angle here and one angle here. All right, so let's start with this one. I'm going to call this theta. When I identify my sides, so that I can identify my opposite, hypotenuse, all that sort of thing, I always start with hypotenuse. Okay, so the idea here is identify the angle that you're going to work with. Then you go ahead and label your sides. All right, so I always start with the hypotenuse because the hypotenuse is the hypotenuse is the hypotenuse. The hypotenuse doesn't change based on the angle, but the opposite and the adjacent will. So hypotenuse is always the longest side of the triangle, or if you're not sure which side is longest, it's always opposite the 90. So this right here is our hypotenuse. Now, the opposite and the adjacent come from the relationship to this angle. I recommend you start with opposite because it's usually the easiest to recognize. So what you look at is you look at this angle and you think which side is completely opposite from this angle. Okay, if I look all the way opposite the angle, across from the angle, this side is my opposite. Okay, that means adjacent, which means next to, is the side that's adjacent to the angle or next to the angle. Okay, the angle will always be formed by its adjacent and the hypotenuse. The hypotenuse, though, is always the longest side opposite the 90, so that's always the one that I identify first. So if I wanted to find the sine of this angle, I would take the opposite length over the hypotenuse length. If I wanted to find the cosine of this angle, I would take the adjacent over the hypotenuse. There's my caught another hippie, so some old hippie caught another hippie. And then the tangent is always the tripping on acid, which is opposite over adjacent. The trig functions don't change, the ratios, they don't change. They're always sine, cosine, and tangent in always this order. What changes is what angle you're given, what angle you're trying to find, and the measures of the sides. Okay, so what I'm going to do is I'm going to go ahead and I'm going to erase this part, and I'm going to put up a new picture. I'm going to actually erase kind of this half, and I'm going to put up a new picture with measures, and we'll look at how you find the sine, cosine, and tangent of each angle. They just need to be flipped. Sorry, we're also trying to do household things while I do this. And we've got dinner cooking and a child that's sick, so it's quite a day. All right, so I've got a triangle. Okay, I'm gonna call this triangle, I don't know, ABC. And I'm gonna make it a triple, which if you don't know what that means, don't worry about it. But I'm gonna make it whole numbers so that it works out nice. It's not drawn to scale. So I'm going to call this one 5, this one 12, and this one 13. Now, what I want you to realize is we're going to find the sine of A and we're going to find the sine of C. We're going to find the cosine of A and the cosine of C. And we're going to find the tangent of A and the tangent of C. But I'm going to do it color-coded because I think that that will hopefully help the process. And I apologize because I'm like thinking ahead in my brain, but my brain's not moving as fast as it needs to. Okay, so we're going to start with the angle A. Here is my angle A. Okay, that's the one that is most similar to the triangle. I don't know if you can tell that this is a green and this is a blue, but we're going to start with this angle. Sine has to do with the side measures. So what I'm going to do is I'm going to label my sides according to this angle. Always start with the hypotenuse. It will always be the longest side or the side opposite 90. So here's my hypotenuse. Okay, the opposite side will always be the side furthest away from this angle, which is the 5. And then the adjacent will always be the side that forms the angle that's not the hypotenuse. So when I find the sine of A, that's my some old hippie, so it's opposite over hypotenuse. So all I do is identify the opposite measure, which is 5, and the hypotenuse measure, which is 13. So the sine of A is 5 over 13. Now, I'm not getting into today, I'm not getting into today right now, the idea of what this means and what you do with it and how it solves stuff. Right now, it's just setting up the trig ratios. Okay, cosine is the caught another hippie, so I have cosine, adjacent, hypotenuse. So I look here again, and here's my adjacent, and here's my hypotenuse. And then tangent is my tripping on acid, which is my opposite over adjacent. So I go back to my angle and I say opposite is 5, adjacent is 12. Right? Opposite over adjacent. Okay, now those have a relationship to the angles here, and you can use them to find the angles. If we were missing a side, we could use trig ratios and the measures of the angles to find the missing side. We're not doing that right now. This is just setting up the trig ratios. Now, here's where you have to be careful. Now I'm looking at angle C. That's this angle here. When I identify the hypotenuse, it's still the longest side. So this is still the hypotenuse, is the hypotenuse, is the hypotenuse, is the hypotenuse. It's not going to change. What will change though, nothing. What will change though is which side is opposite C. Now the side that's completely opposite C is here, and the side that's adjacent to C is here. So what happens is, when you change angles, the opposite and the adjacent will exchange. All right, so you need to be careful because just because I have this labeled adjacent here doesn't mean it's always adjacent. It's adjacent to this angle. It's opposite to this angle. All right, now though, sine is still opposite over hypotenuse. However, now I'm looking at the sine of C. My opposite is now 12. My hypotenuse is 13. Okay, for my cosine of C, cosine is my caught another hippie, which is adjacent over hypotenuse. So adjacent now for this angle C is 5 over 13. I keep wanting to write something that's not right. All right, then my tangent of C is opposite over adjacent. So from this angle, my opposite from this angle is 12, and my adjacent is 5. So what you should notice about the pattern of trig ratios is that the sine and the cosines exchange, like they flip, when you change angles. So here was my sine of A was 5 over 13, and that matches my cosine of C. My cosine of A was 12 over 13, and that matches my sine of C, because it's dependent upon the angle that you look at. Now my tangents, notice, have the same numbers in them, but because the opposite and the adjacent switched, the opposite and the adjacent in the fractions switched. If you are in my current class and you're working on the assignment for this, don't worry too much about the radicals. For some reason, Eureka doesn't bother simplifying them, and we can deal with that later. That's another level of life. All right, the idea here is that you need to be able to identify the sides and identify sine, cosine, and tangent. All right, if you were in my current class, what we'll do tomorrow is we will talk about how you actually use these, like what's the point of them besides just finding fractions. Because like I said, what will happen is you'll be given this triangle and it'll be missing this side. Or you'll be given this triangle and it's got this side, but now they want us to find this angle measure. And we can use trig ratios to do that. All right, that's not what this is today. All right, I said this 3 times now. This is simply setting up the ratios. That's what we practiced in class today. That's what we worked on. Because if you can't set up the ratios, it doesn't help you to try to solve with them. All right, I will do a recap for class tomorrow if you are in my current class. All right, but it will take some practice. Okay? All right, trig ratios. Have a lovely rest of your day.